Good morning friends, welcome to the teleconferencing session of School of Agriculture. Today we will be covering the diploma program in value added products from fruits and vegetables, and we will be covering the course 4, Processing Engineering 1. Friends, you know this course consists of 4 blocks. Block 1 is Introduction to the Food Processing Engineering. Block 2 is Unit Operations. Block 3 is Development of Fruits and Vegetable Products, and Block 4 is Plant Layout. We have structured the 2 sessions in such a way that the first 2 blocks will be covered in the first session and the remaining 2 blocks will be covered in the next session. For the first session, we have with us Dr. D.V. Samuel, who is the Head Post-Harvest Technology Division, IRI Pusa. He is man of food processing engineering from a premier institution, IIT Kharagpur, and I am sure the subject cannot be handled better than anyone else by him. So I will request Dr. Samuel to tell us about the food processing engineering.
Thank you, Dr. Saluja, for a brief introduction about me. As you are aware that food process engineering is a very important area in our lives. Food is one of the very important aspects of our life in the sense that it is one of the major lifelines of our own doing things, our working, and we do require energy for day-to-day life. People go to work, housewives work at home for their domestic life. So we all need energy, and energy comes when we eat our food. So food is very important for our lifestyle. Food process engineering is an important area in the area of foods. The reason being that food cannot be taken straight away. Food needs to be processed before it is taken and consumed by human beings. The main idea of processing the food is not only to convert it into a palatable form, but also to make it free from pathogenic microorganisms which spoil the food when it is kept for some time. We need to work hard to see that the food which is served to the consumer is in a better form, it is more attractive, it has a good appearance, it is palatable, and it is also safe. And in order to do that, the food process engineering becomes very important. Today, I would like to present to you some of the important concepts of these 2 blocks which I am going to present to you. I am not going to present to you everything, but I am going to select very specific aspects of these 2 blocks, and we will pick up one point after the other. Later, if you need, you can ask questions and we will answer those questions. First of all, I would like to talk to you about the necessity of the processing of food. Why do we process food? Once again, the idea is, the concept is used to determine how long it takes to kill a specific microorganism at a specific temperature. I am presenting before you a slide. Please look at the slide, and you see on left hand side on the y-axis we are showing thermal death time in minutes. On the right hand side it shows both these things are correlated. In order to inactivate the bacteria which is causing you harm to your body when you take it along with your food, we need to inactivate it by subjecting it to temperature or heat, and we do it by various means. Thermal death time comes into play when we have to heat it at a particular temperature for a particular time. For example, a particular acidic food bacteria by name Clostridium botulinum, it has a spores which is most resistant, and if we have inactivated this bacteria in the food by heat processing, it means all the other bacteria which are not so resistant, they are also taken care of. That is why what we do, we take a particular bacteria which is most resistant and use a time and temperature combination so that we have inactivated this bacteria, and by inactivating this bacteria we have inactivated all other bacteria also. I'll give you just one example how we go about doing the inactivation of bacteria, like sterilization. You must have heard the name of ultra high temperature treatment. Ultra high temperature treatment is a high temperature short time process where we sterilize the product against any bacteria. For example, milk. When we sterilize milk, we sterilize it by UHT processing, and in that 130 to 135 degrees centigrade temperature is used for fraction of a second, and there we have done our job. Similarly, if you want to sterilize any other product, for example, if you see on this graph, if you want to sterilize or pasteurize a product at 110 degrees centigrade, then the time taken will be nearly 30 minutes, if you see in this graph. If you want to use 120 degrees centigrade temperature, the time taken will be a little over 1 minute. So these temperature and time combinations, they become very important as far as the thermal death time of the product is concerned. Also, many a times, thermal death time is significant in the sense that particular material, like for example vegetables and fruits, when they are stored, they also have bacteria, and inactivation of this bacteria to make the food safe from spoilage is also taken as a sign of thermal death time. We will proceed further from here. I will show you my next slide. The next point which I have taken for you is the refrigeration system. One way of preserving food is heating, as I have told you just in the first slide. The second way, very common way of keeping the food safe, is vapor compression refrigeration system. You must have seen in all our homes we have got a refrigerator, and this refrigerator is packed with food items so that these foods can stay longer. As far as all other foods are concerned which have been processed earlier, they can be kept inside it and they will stay longer. However, some of the unprocessed food also, for example vegetable and fruits, meat, egg and other poultry products, milk products like cheese, like paneer and many other products, they are kept inside and they are used for food purposes later on. I will just would like to tell you, because this forms a part of your block 1, how this system works. Please look with me into this diagram which I am going to show to you. Please see this diagram. The vapor compression refrigeration system, it consists of 4 to 5 important elements. The first one which I am going to show to you is the evaporator. My arrow is there, you see, evaporator. The second one is compressor. This is a very important element again. Then we have got the third one as condenser, and then the fourth one is expansion valve. I'm sorry, I have lost the mouse. Yeah, expansion valve. Apart from these 4, we also have one very important element which you can't see in this diagram, and that is a refrigerant. That is a refrigerant. The refrigerant flows in the pipes which you see here, like this. Refrigerant is a chemical or a liquid which is used inside these pipes for cooling purposes. Most of the refrigerators or vapor compression refrigeration systems, they use Freon 12, which is one of the chemicals, and it is used for refrigeration purposes. Let me start from the evaporator. What is the evaporator? Evaporator in your refrigerator, please assume that you are looking at your refrigerator. Evaporator in your refrigerator is the cabinet space in which you store your food products. You must have seen the coils just below the evaporator or that cabinet space. These coils, they do the purpose of absorbing heat from the products. So in evaporator, the heat produced by the food product is absorbed, and the refrigerant which is going inside the pipes, please look with me with my pointer here. When the refrigerant is going inside these pipes, it absorbs the heat from the food products, and then it becomes heated. And earlier it is in the liquid form, but later on, due to the heat absorbed from the product, it starts boiling and it comes into a vapor form, that is gas form. Then from there, then from there it flows into the pipe in the form of gas. Look with me into this, into the pipe, and it comes to the compressor. Mind it, at the evaporator it has cooled the product and it has become gas, and it is now going towards compressor. When it reaches the compressor, in the compressor this gas or vapor of the refrigerant Freon 12 is compressed and its pressure is raised here, and from here it flows to the condenser. See here, this is the condenser. The function of condenser is that it will liquefy the refrigerant again. From vapor form it will become the condensed form, that is liquid form. From here it will travel to the refrigerant receiver, and then it will go up into the pipe and reach the expansion valve. By adjusting the expansion valve, we can reduce the pressure of the refrigerant. When you reduce the pressure of the refrigerant, then it goes through the valve, and then it will go again to the evaporator, and it will do the same job of extracting heat from the product, and then the same cycle will follow. I hope that you have understood how the vapor compression refrigeration system works. Nowadays, the Government of India and many private organizations, they are using vapor compression refrigeration system in their moving vehicles, and that is known as cold chain. For example, if you have to take a product from one point to the other without refrigeration, the material is likely to spoil due to the temperature difference from the refrigerator to the atmospheric. But if you have a vapor refrigeration system in a vehicle, then it will help you to keep the product and its shelf life much longer. Now I'll come to the next time to show you the actual working of this thing. Now this is the actual picture. If you see here, these all pipes and all these things. Now here you see here we find there is a compressor and so on. So out of this you will find that this is nothing but, like for example, this is cooling coils at overhead. This is a thermometer which is shown. So this is a technical diagram to show you, but the previous diagram would have helped you to understand the vapor refrigeration system. Now connected to vapor refrigeration system, there are certain terms, and one term which is very important is cooling load. What do we understand by cooling load? The cooling load is the rate of heat energy removal from a given space or object in order to lower the temperature of that space to a desired level. For example, when you have stored your product inside a refrigerator has to take away the heat from the product and keep it cool, and there is a certain load which is known as cooling load. Now how do we express the cooling load? It is expressed in commercial practice as ton of refrigeration. You must have heard that people, when they install air conditioners in their homes, in their offices and in the shops, you will ask them, they will say it is 1.5 ton air conditioner or 2.5 ton air conditioner. The ton of refrigeration is equivalent to the latent heat of fusion of 1 ton of ice, that is 1000 kg into 336 kilojoules per kg per 24 hours. So 1 ton of refrigeration is defined as 3.888 kilowatt. If you see here, 3.888 kilowatt. Another term which is associated with refrigeration is COP, that is coefficient of performance. It is the ratio of useful refrigeration effect obtained from the system to the work expended on it to produce that effect, and it is normally expressed as H2 minus H1, H3 minus H2, whereas the term on the upper side is heat absorbed by refrigerant at evaporator, and the term below, denominator, is energy supplied to the compressor. Now coming to the next very important aspect in the food process engineering is evaporation. Let us try to understand what is the difference between evaporation and dehydration. Many times we confuse the two terms, but they are distinctly different from each other. Evaporation is an important unit operation commonly employed to remove water from dilute liquid foods to obtain concentrated liquid products. For example, manufacture of tomato puree from juice. Removal of water from foods provide microbiological stability and assists in reducing transportation and storage costs. Evaporation differs from the dehydration since the final product of evaporation process remains in semi-liquid form. Dear friends, you must have seen in the market a product which is known as condensed milk. Now, how this product condensed milk is obtained? Condensed milk is nothing but evaporated milk. Milk contains large amount of water, and once the water is evaporated from the milk, the remaining substance is nothing but condensed milk. One difference between the dehydration and evaporation is that in case of evaporation, the final product is never a solid product. It is either a semi-solid or a semi-liquid product or liquid product. Whereas in case of dehydration of a product, most of the time the remaining product which you get is a solid. So these are the two important things. Later, if at all time permits, we'll discuss also about different type of evaporators. What are the machinery involved in evaporation and how we affect it. Let us go to the next important point, that is equilibrium moisture content. Let us look into this, why equilibrium moisture content is important to us. I would like you to understand it in this way. Whenever any object or food material is subjected to an external environment, they start interacting. You keep a seed or a food product in the open, you will find that the external environment and the seed or the food will start interacting. What kind of interaction goes on between the two? The main thing is that whenever the two are exposed to each other, they start communicating with each other, and you will find that they want to come in equilibrium with each other. For example, if you put your food into an atmosphere, you will find that the relative humidity and temperature of the surrounding atmosphere and the relative humidity and temperature of the food product after some time, say after a gap of few hours, will become same. That is, they will reach an equilibrium. What happens during this process is, if you are putting the food to an external environment which has a higher temperature and relative humidity, you will find that the food will gain moisture from the outside product. You must have seen during the rainy season, if you put something which is very dry product outside, later on you will find that it becomes soggy, it becomes moist. The reason being, the product has interacted with the outside atmosphere and it has attained higher moisture content. It has taken the moisture from the air. Also, there is interaction between the product and atmosphere when a process of drying goes on. In the case of drying, the process is just reversed. What is done in drying? That a hot air with high temperature and low relative humidity is forced on the moist product. So in that case, what happens? The air, it takes the humidity and temperature from the product and makes it dry. So this is how the equilibrium moisture content is important to us. I will again define it for you. Equilibrium moisture content gives an idea whether the food material will gain or lose moisture at a particular atmospheric condition. It gives an idea about rate of moisture removal. EMC helps to determine drying characteristics. With the knowledge of EMC, it can be predicted as to what final moisture level a product can be dried with the heated air. Next important point which is related to EMC is the hysteresis effect. As I just told you that we have been using product for drying purposes and also for wetting purposes. If you see this particular diagram of hysteresis effect, on the Y segment you will find percentage gas humidity. On the x-axis you will find moisture content in dry basis, and you will find two curves. One curve is going up, if you see that, one curve is going up and other one is going down in this way. The one which is going up, what it is doing, it is taking the moisture from the surrounding atmosphere, and see the humidity, if you see here, it is increasing in this fashion. This is known as sorption isotherm. When the product is subjected to a drying atmosphere where the moisture is lost by the product, then we will find that it is known as desorption isotherm, where it loses moisture from within to the outside atmosphere. But something very peculiar I would like to show you here. For the same product and for the same condition, you will find the curve does not take the same route. The way it has gone up to this point, and in a drying atmosphere it is coming back, but it is not following the same point. It is coming down. So there is a loss of energy in between, and you see here, and that is known as hysteresis effect. Now coming to the separation. Separation is very important aspect as far as processing of food products is concerned. For example, if you have to process your product wheat for converting it into atta, you have to process pulses for converting it into dal, and you have to process maize or corn into atta or other products, you need to use a separator. I have chosen here a magnetic separator to show you that how this important separation mechanism works. There are many other separators which are available. There are separators which are based on the size of the product, so they will separate on the basis of the size. For example, you have got pulses which are having different sizes, a admixture of pulses. For example, 2 mm, 3 mm, 4 mm, even up to 5 or 6 mm size. They can be separated with the help of a size separator. Similarly, there are mechanisms which separate on the basis of shape. If the two products are mixed, they can be separated on the basis of shape. For example, paddy, which is oblong in shape, and the mustard seed, which is very small and round in shape, it can be separated with another type of separator, which is known as size shape separator. Then we have got different other type of separators, but let me concentrate on magnetic separator because this forms a very important part of the separation mechanism. Now, how and what it separates? Magnetic separator separates products which are mixed. For example, two types of seeds of grain which have got accidentally mixed, and one of them have affinity to liquid and another one does not have affinity to liquid. What I mean to say when I say affinity to liquid is that if you see, you will find a certain type of seed or grain, when you spray moisture on it, it will absorb moisture and its outer coating will become wet. Whereas there are other type of seeds whose outer coating is not affected by the spray of water, and it will not absorb the water in its outer surface. So now we have got two types of materials, food grains, one which absorbs water and another which does not. How do we separate the two? You see here in this hopper, which shows the number 1, we are keeping here our mixed material here, and then its material is coming into the screw conveyor. These are the screw flights. You put the material here, and as the material comes here, at point number 2, water is sprayed. A very thin film of water covers the seeds. Now the seeds who have affinity to liquid, they will absorb the moisture, and the seeds which do not have affinity to liquid, they will not absorb the moisture, and there will be no effect on them. Now these seeds will travel along with the screw flights, and when they come to point number 3 here, a very fine iron powder is sprayed here. Now try to understand, the iron powder, when it is sprayed on the product, it will only deposit and stick to those seed product which has affinity to liquid and which has got moisture still sticking to it. The one which does not have moisture will not take this iron filling. From here, the product will then finally travel here, and it will be exited from this point. Now come here, you will find there is a big drum here. This is nothing but a magnetic drum, and with the help of electrical connection, it is magnetized. Whenever electricity is produced, it is magnetized. Otherwise, a natural magnet can also be used. Now as the product files past from this output and it comes on the surface of the magnetic drum, you will find that the product which has an iron filling sticking to it, it will continue to stick and getting attracted towards the drum, because drum is having a magnetic nature. Whereas the clean seeds which have not got the iron filling powder on them, the clean seed will fall straight, and the product sticking to it can be taken out with the help of a brush which is shown here, and the two products can be separated. Now after we have cleaned our product with the help of a separator, and we also have the point how to store this product. Many times you will find that during the storage, you will find our product, it gets infested, it gets spoiled, and there are several reasons why the product gets spoiled. Now there are spoilage and infestation sources that we have. First is the field, second was infested bags, then infested transport, infested go down, and infested stocks. I'll explain you each term, that how the infestation comes. Number 1, the infestation from the field. The product, either grain or vegetables, when they are harvested in the field, what happens that in the field also there are many infestation sources, microorganisms for spoilage. They get admixed with the product in the field, and when you collect them and bring them to your storage place, they start spoiling your product. Then the second stage of infestation is through the bags. If you are using old bags, or even sometimes in the new gunny bags, in the crevices and the folds you will find some of the insects, they are hiding, and as soon as you have put your material inside it, they start attacking the food grain and they spoil it. The third type of infestation comes during transport of the product. Many a times you will see that product in the villages is transported through bullock carts and also through tractor trolleys. You will find that in these particular tractor trolleys and bullock carts, they are not cleaned properly by the villagers. Even the transport during truck also, the truck is not cleaned once it has transported the product. Now what happens, the insect or infestation which is there in the product, it remains in the tractor trolley, in its crevices, in its broken wooden areas, and it hides there. When you have put the new product or new stock on the transport trolleys, the same material will come and it will infest the fresh product and it will spoil it. Infestation is also seen being done in godowns also. You must have seen large government godowns which house the products in the form of, you will find bulk storage as well as the bag storage. Godowns also, if they are not properly disinfested with the help of certain chemicals, you will find that many of the infestation which occurs in the product is through the godowns. Because when a product is removed from the godown, and if it is not properly disinfested, the infestation persists there. And when a new fresh bags of food grain comes there, it will again get into it and it will spoil it. And one of the final things I would like to tell you about the infestation is infested stocks. Supposing you have an infested stock of grain, probably in a form of gunny bags, and if you put along with this the other good bag, what will happen? The old bag which is infested will infest the new bag which is clean. So when we are storing the product, we must keep in mind that all these precautions are taken beforehand. Now, as far as the storage, we have been discussing the storage of the food grains. Now let us come to the storage of fresh fruits and vegetables. Here I would like to give you a diagram and explain to you that in Indian Agricultural Research Institute, where I come from, we have devised and developed and modified and seen that a zero energy cool chamber is helpful on the farm level to protect the foods, especially the fruits and vegetables, from spoilage. You see, it is a very simple diagram. Even a farmer can make it at his home. You see here, these are the outer brick wall. It is made of standard bricks outside, and then there is an inner brick wall, again made of standard bricks. It is, if you see here, in between the two walls there is a gap of 7.5 centimeter here. The gap is given to fill the wet sand inside. So what is done? First, the floor is made with the help of the fresh bricks. Mind it, please make always with the new and fresh bricks. Don't use the used bricks for this purpose. And then you will find here, once we have made the wall, then we have filled in between the wet sand. Please use the riverbed sand. Don't use the dirty sand. Before using the sand, please clean it with the help of a sieve. Take out all the foreign material from that, and then you use it. Now once you have filled the sand, then you will wet it properly, and then inside, if you see in the next diagram, the black diagram, inside in crates we will put our materials. And then the water, if you see here, this one we have slightly mechanized in a sense that we have provided water pipe here, and see here the pipe goes and it is attached to a storage mechanism, water storage mechanism here. You can use a black color of water tank here and then attach. So what happens, the water will come through this pipe and it will slowly keep the sand wet. When the sand is wetted throughout the 24 hours, you will find the effect, and you will see that your food product, especially the fruits and vegetables, they can be kept very safely in this particular product. You will find here also that we have used on top here a small bamboo made of khaskhas material, which is to protect the food inside from radiation and also not to allow the direct sunlight on this. I would like to show you how this one works and how effective it is. Look at the table which I am showing you. We have done experiments on this, and you find that mango, when it is kept in the month of June and July inside the cool chamber, it stays for 9 days, whereas if you keep it at the room temperature outside in the house, it stays only for 6 days. Similarly, if you see banana, it can stay for 20 days inside the cool chamber as against 14 days outside. So you are getting an advantage of keeping the material for 6 more days with the help of this particular product, this technology. Sapota also, instead of 10 days, you can store it for 14 days. But the maximum, if you find here, that Kino orange, if you keep the Kino orange, you can keep it, instead of 14 days outside, you can keep it for 60 days, which is nearly 4 times the amount of time for which the material can be safely stored in the cool chamber. Also, if you see potato can be kept at room temperature only up to 46 days, whereas potato inside the cool chamber can be kept for 90 days, more than twice the time. Similarly, even product like methi means the green leaves. Green leaves can be kept instead of 3 days outside, they can be kept for 10 days inside. Amaranth that is chaulai, it can be kept for 3 days instead of 1 day. And okra, that is bhindi, instead of 1 day you can keep it for 6 days. So you can see the advantages of this technology. The technology is very simple. You can very easily use it at your home. It can be made at home, at your domestic level, as well as at the farm level. Apart from this, the another advantage of this particular technology is that it is a low cost technology. You can make it for nearly 3,000 to 4,000 rupees. The structure can be built, easy to maintain, and not only that, it does not require any energy. That is why we call it zero energy. It does not require energy to run. No electrical energy is required to run it. There is no fan, there is no motor, there is no compressor, and an ordinary villager can maintain it. It's a low cost technology, and this particular technology has been popularized. Now coming to the second block of your system, we need also for our food to reduce the size of the product. Like for example, if you are eating roti, how you are eating roti or chapatis? You are eating it because you have taken wheat, you have ground it, made it into fine powder, that is called atta, and then our ladies at the home, they prepare chapatis, we eat it. So size reduction machines are very important. You have reduced the size of wheat from a big grain to powder. Similarly, for using pulses, for example, if you are going to cook dal, the dal does not come in the same form from the field. Pulses have to be taken out, and then the size has to be reduced. Since pulses are dicotyledons, you can split them into two and then cook it at home. That is why the size reduction machines comes into play. For example, I will show you some of the size reduction machines which are here. They are on your panel. You can see there are crushers, jaw crushers, gyratory crushers, crushing rolls. Now most of these crushers are used for reducing the size and making them into either granular form or in the form of powder. Then you see we have got grinders. Grinders are nothing but under this category comes hammer mill, attrition mill, tumbling mill, and rolling compression mills. See here, this is attrition mill, this is a hammer mill. Then you find ultra fine grinders. These ultra fine grinders, they are used for very specific job where the material, the size have to be reduced and made into very fine powder. And there are cutting machines also to reduce the size to the coarse level. So these are some of the size reduction machines. I will take up one machine. There is attrition mill, which is more popular because each one of us, we eat atta, and you must have gone to grind the atta at the atta mill. And attrition mill is one such machine which is used for milling the flour, and that is milling the wheat into flour. Now see here, this is a machine. It has got one rotating disc, as it is clear on your panel. This is rotating disc, and then there is one stationary disc. Only the rotating disc rotates. The RPM can be anywhere around 1000 to 3000 RPM, and it is all housed in a casing. Material is fed from here. There is a word feed written. Material is fed from here, and then it is directed from the center of the stationary disc into the compartment. As soon as the wheat or any other product or chana comes inside, the rotating disc immediately takes care of it and grinds it to the required level. Also you will find that there are small levers which are given here. These levers are used so that the clearance between the two discs can be maintained. For example, a particular product may need less clearance, and some other product for grinding it into besan or maida may need different clearance. So it is used. These machines are electrically operated, very efficient and very useful for our domestic market. I will also show you some of the important things like material handling devices. Now these material handling devices, if you see with me on your TV panel, you will see here these are belt conveyors, roller conveyors, chain conveyors, screw conveyors, vibratory conveyors and flight conveyors. All of these find their uses in the material handling of food products. For example, if you see, this is a belt conveyor. Belt conveyor is used for the materials like granular materials. For example, grains. If you want to transport grains from one point to the other, you can use that. Even other than grains, matters petitious like lime, cement, sand, they can be transported with the help for a longer length. Then come to the roller conveyors. Roller conveyors, if you see here, these are used for transporting bagged product, like for example gunny bags, plastic bags which have contained material in it. They can be transported from one place to the other with the help of roller conveyors, or also used for transporting cartons which is filled with the material. Also you see here we have got chain conveyors which are used in the industries for transporting the bottled and other material. Then we have got vibratory conveyors. Vibratory conveyors are very important in the sense they are used to give powdery material, feeding of powdery material. For example, powdered milk, powdered charcoal, for powdered atta, anything you want to feed, the vibratory material comes into hand. And then we have got screw conveyors. Screw conveyors are used for transporting granular material from one place to other place, but the disadvantage is screw conveyors cannot transport the material through a longer distance. They can transport the material to only shorter distances. Another very important elevator is known as bucket elevator. Bucket elevator finds its use in food industry, it finds its use in grain industry, in seed industry, and all other places which require material to be lifted with the help of small buckets. I would like to just show you its construction. It has got a undless belt which is rotating, and on the belt you will find that there are small buckets, and these buckets, they lift the material and they dump it into it. So that's how these are used again for a very short length of material. I would like to just show you here that if the bucket elevator, the bucket speed is low, then it is not good. The too slow speed gives spillage. Optimum speed will give you proper efficiency, and fast speed will give you again a problem, which is seen here in the product. About the food packages, can you see in your panel there are certain food packages we have given. Glass bottles are used, CFB boxes are used for packaging of material, Tetra Pak, we have got wooden boxes, and we have got all other type of assorted material here which is used for packaging. See the various household packaging types for food you see here. There is also another kind of food packaging which is known as modified atmospheric packaging, and you will find in modified atmospheric packaging, product is kept along with an inert gas. For example, you must have Lay's chips, you must have seen Uncle chips. All these things are known as modified atmosphere packaging, where an inert gas is put inside so that whenever you open the pack you will find that the material is still crisp and fresh. That's how it is done. Yeah. And you will find here that these are some other kind of plastic net bags which are used as packaging of onions. You see here potato, and these are capsicum, and you'll find here this is nothing but marigold is being done here. And with these words I would like to thank you for very patiently listening to my lecture. Thank you very much.
Thank you, Dr. Samuel, for giving a very complex topic into a very simple way. Thank you very much.